put together for an exceptional cosmic event on the horizon. A big purple, massive, big name placed at the threshold of our galaxy is emitting mysterious alerts throughout the universe. Utilizing the Jansz Net Space Telescope, astronomers have made unsettling discoveries approximately this large celestial body. Renowned astrophysicist Brian Cox issues a serious warning, raising the question: are we getting ready to witnessing a catastrophic supernova explosion that ought to completely alter our nighttime sky? Let's delve into the details within the large expanse of the cosmos wherein stars come to life, thrive, and sooner or later meet their end in a spectacular display. One big name has lately captured the attention and difficulty of astronomers and the public alike. That big name is Betelgeuse, a red extraordinary giant of mammoth proportions and age prominently placed in the Orion constellation. While its precise reddish hue and varying brightness have long interested observers, recent traits have intensified hobby within the celestial giant. As we discover the character of Betelgeuse, we discover ourselves on the verge of a potentially enormous occasion inside the star's existence cycle. But what could those modifications in Betelgeuse represent? Are we witnessing the prelude to an unimaginably grand cosmic spectacle? Betelgeuse, approximately 764 instances larger than our Sun, stands as a stellar behemoth of significant length, almost beyond human comprehension. Imagine a star so massive that if it were to replace our Sun, its surface could extend beyond the orbit of Mars, enveloping Mercury, Venus, Earth, and Mars in its stellar embody. This notable length no longer most effective showcases Betelgeuse's physical attributes, but additionally highlights its stage inside the stellar existence cycle. As a red high-quality large, Betelgeuse is in the twilight of its existence, marked by expansion and cooling after a lifespan fusing hydrogen into helium in its core. Regardless of being exceedingly younger in human terms at around 8 to 8.5 million years old, Betelgeuse's current red incredible massive phase is the result of millions of years of stellar evolution, transforming from a hot blue star to the purple giant we see these days. Betelgeuse's unique reddish hue stems from its cooler surface temperature in comparison to stars like our Sun. Whilst the Sun's surface temperature is ready 5,500 kinfolk, Betelgeuse's cooler surface registers temperatures around 3,000 to 3,500 Kelvin, emitting mild at wavelengths that give it a purple look. This coloration isn't just visible but offers insights into the star's physical situation and the tactics inside its widespread gaseous expanse. Adding to Betelgeuse's mystique is its ancient shade change. Ancient Roman and Chinese writings advise it was a yellow big name approximately 2,000 years in the past, with Arabic scholars first describing it as pink within the 9th century. This shade shift over human history provides valuable clues approximately the star's evolutionary course. The variable brightness of Betelgeuse is similarly fascinating. As a semi-normal variable superstar, its mild periodically waxes and wanes in a characteristic dance of luminosity following a 400-day cycle and an extended cycle spanning approximately 5 years. These cycles have been documented since 1836 via Sir John Herschel and possibly even earlier in Aboriginal oral traditions. However, what provides to the thriller of Betelgeuse is not simply its changing brightness, however, its irregularity. In contrast to many stars that follow a predictable sample, Betelgeuse once in a while deviates from its rhythmic dimming and brightening, hinting at complex and much less understood tactics inside its gigantic form. In a current groundbreaking revelation, Betelgeuse grabbed the interest of astronomers and stargazers worldwide with an unexpected and dramatic exchange in its look, famously known as the first-rate dimming. In overdue 2019, the purple exquisite large Betelgeuse, one of the brightest stars in the night sky and a prominent characteristic of the Orion constellation, began to mysteriously dim. The superstar's dimming changed into so mentioned that it started losing its luminosity at an average rate of 0.1 magnitudes according to Day, attaining its lowest brightness in February 2020. Betelgeuse, normally visible to the bare eye even in mild polluted regions, became incredibly fainter, a change even amateur observers could come across. But there is a task while seeking to screen Betelgeuse's sports: the time paradox. When we study a star like Betelgeuse, we are not seeing it because it exists in the gift, but because it was in the beyond due to the time it takes for mild to tour to us. In Betelgeuse's case, approximately 725 light-years away, the light we understand today left the star almost 7 centuries in the past. This time lag makes it hard to our expecting and reveals sudden modifications in a celebrity's behavior, as we're basically peering into its past. Andrea Dupree, partner director of the Middle for Astrophysics at Harvard and Smithsonian, and her crew intently monitored the unfolding celestial drama using the Hubble Space Telescope. They analyzed the behemoth star as a part of a 3 to 12 months look-at to monitor variations in Betelgeuse's outer ecosystem. These observations provided unique insight into the dynamics of a variable superstar like Betelgeuse, which frequently expands and contracts, causing fluctuations in brightness. Hubble's sensitivity to ultraviolet light allowed researchers to probe the layers above the famous person's surface, heated partly by way of the star's turbulent convection cells. Further analysis of the Hubble spectra taken at distinctive points all through 2019 and 2020 helped measure the motion of fabric in Betelgeuse's outer environment, specifically specializing in magnesium Roman lines indicative of the star's atmospheric conditions. These observations discovered cloth transferring at speeds of about 200,000 miles per hour from the star's floor into its outer atmosphere. This hot, dense cloth eventually extended millions of miles from Betelgeuse and was the precursor to the dirt cloud that caused the celeb's dimming. Dupree and her crew envisioned that approximately twice the everyday quantity of material from Betelgeuse's southern hemisphere became misplaced over the 3 months of the outburst. This mass loss becomes sizable, in particular considering that Betelgeuse, like all stars, constantly loses mass, albeit at a rate a ways greater than that of our Sun. The dimensions of this mass ejection and the subsequent dimming sparked discussions amongst astronomers about whether this event might be a precursor to a supernova explosion. The proximity of Betelgeuse, about 725 miles from Earth, adds to the intrigue, as such an explosion might be visible from Earth and provide an extraordinary opportunity to look at a supernova up close. But the query stays: what does this dimming event intend for Betelgeuse's future? Is it a hallmark of an approaching supernova or surely a unique episode in the star's long existence? Several theories have been proposed to explain this unexpected exchange. One typical concept suggested a phase in the supernova explosion method, gaining traction because of the commonplace belief that Betelgeuse is nearing the cease of its life. Another widely discussed theory pointed to the possibility of dirt, potentially originating from Betelgeuse itself, obstructing our view. Red supergiants like Betelgeuse are recognized to shed fabric, and it was suggested that this cloth should form a dense dirt cloud, causing a dimming effect when viewed from Earth. Another explanation considered adjustments in the star's photosphere, the visible surface layer, which might have an effect on its apparent brightness. To unravel this thriller, an evaluation the use of numerous observational methods was employed. Spectroscopic research discovered the decline in Betelgeuse's powerful temperature, indicating that the dimming is probably attributed to a big dark spot at the star surface. Supporting this principle turned into the statement that Betelgeuse's temperature dropped by using as a minimum 170 Kelvin around the time of the dimming, suggesting tremendous surface modifications. Ultimately, the breakthrough in know-how this unusual event got here from the Hubble Space Telescope, humanity's watchful eye in outer space. Hubble's observations indicated that Betelgeuse's dimming was probably prompted by using a full-size ejection of warm cloth into space. This fabric formed a dirt cloud that obscured a portion of the star's surface, diminishing the quantity of mild achieving us from Betelgeuse. Consequences are profound, hard traditional understandings that red supergiants shed mass at a steady pace before their explosive demise. Instead, the size of this ejection suggests a more turbulent and probable unpredictable end-of-life segment for these stars. Could Betelgeuse be gearing up for its grand finale, a supernova explosion within the following couple of millennia? Recent research speculates approximately the timing of such an event, suggesting it may arise sooner than previously thought, doubtlessly in just a few tens of years. Every other essential component in the Betelgeuse puzzle is the idea of bow shock. As this massive star moves through space at approximately 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow surprise akin to the wave fashioned through the bow of a transferring deliver. This phenomenon takes place because the star's outer layers engage with interstellar gases and dust, providing an astounding testament to the star's dynamic nature and its interplay with the cosmic surroundings. Examining this bow shock no longer most effective informs us about Betelgeuse's current nation but also contributes to our knowledge of stellar evolution and mass loss techniques. However, what approximately Betelgeuse's recent behavior? Observations display that Betelgeuse's surface has cooled and come to be less dense following the huge ejection occasion, leaving the star in an unstable state even years later. Hydrodynamic simulations advocate a hyperlink between the star's convective activities, the mass ejection, and subsequent pulsation mode switching. This ongoing instability increases questions about the inner processes driving these modifications and how they might unfold in the future. Furthermore, Betelgeuse's observed mass loss V is substantially higher than many other stars, indicating a complicated set of occasions surrounding its evolution and behavior. The saga of Betelgeuse is some distance from over as astronomers return to monitor and have a look at this enigmatic star in search of solutions to the profound questions it raises about stellar life cycle, supernova explosions, and the character of the universe itself. In conclusion, Betelgeuse stands as a cosmic surprise, a giant among stars whose every flicker and trade captivates our imagination and pushes the limits of our knowledge. Whether it heralds the dawn of a remarkable cosmic occasion or in reality marks another chapter within the ongoing saga of stellar evolution, Betelgeuse remains a beacon in the night sky, reminding us of the vastness and complexity of the cosmos. Recent advancements in our understanding of Betelgeuse have illuminated its complicated dynamics and hinted at destiny astronomical marvels. The star's variability, specifically its semi-everyday dimming and brightening cycles, keeps to intrigue astronomers worldwide. These cycles, observed since the 19th century, are pivotal in interpreting the underlying mechanisms governing Betelgeuse's conduct. Moreover, Betelgeuse's recent exquisite dimming event in late 2019 captured worldwide attention and sparked extensive scrutiny. This unheard-of dimming, wherein the star's luminosity dropped substantially, posed fundamental questions about stellar evolution and potential catastrophic events like supernovae. Astronomers mobilized ground-based telescopes along with space-based observatories just like the Hubble Space Telescope to scrutinize the star's each fluctuation and atmospheric disturbance. The aftermath of the splendid dimming found out fascinating insights into Betelgeuse's outer atmosphere. Observations indicated a rapid ejection of superheated material from the star's surface, forming a dense dirt cloud that partially obscured its brilliance. This phenomenon provided an unprecedented glimpse into the dynamics of mass loss in red supergiants, dropping mild on techniques that influence the future of big stars. As astronomers retain to monitor Betelgeuse, the star's spectral evaluation has unveiled exciting shifts in its chemical composition and atmospheric dynamics. Versions in spectral traces, consisting of magnesium Roman II lines, provide clues about the star's internal processes and ongoing evolution. These spectral research, combined with theoretical models and simulations, make contributions to a greater comprehensive expertise of Betelgeuse's complex conduct. Moreover, Betelgeuse's proximity to Earth at about 725 mild-years offers a unique possibility for specified statement. Astronomers leverage this proximity to examine the star's pulsations, convective movements, and interaction with its surrounding interstellar environment. Each remark deepens our information of red supergiants and their pivotal role in shaping the cosmos. One of the lingering mysteries surrounding Betelgeuse is its variability in brightness. Even as most red supergiants showcase periodic brightness fluctuations, Betelgeuse's irregular dimming occasions defy conventional motives. The star's recent dimming occasion, although incredible, raised concerns approximately the potential for a supernova explosion in the near future. However, astronomers emphasize the need for continued observation and data collection to determine whether those dimming events are precursors to such cataclysmic activities. Moreover, research of Betelgeuse's bow shock phenomenon has yielded valuable insights into its interaction with interstellar medium. The star's swift movement through space generates a surprise wave that shapes its surrounding environment, providing astronomers with a unique laboratory to look at astrophysical techniques at play. These research now not most effective enhance our knowledge of Betelgeuse, however, additionally make a contribution to broader research into stellar astrophysics. In latest years, advancements in observational generation have revolutionized our potential to observe stars like Betelgeuse. From ground-based telescopes prepared with adaptive optics to space-based observatories capable of capturing high-resolution pics, those tools have enabled unprecedented insights into the lives of stars. Collaborative efforts among international studies groups have additionally expanded our information base, fostering a worldwide change of ideas and discoveries. Looking in advance, astronomers are poised to confront new challenges in unraveling Betelgeuse's mysteries. Destiny missions inclusive of the James Webb Space Telescope promise to unveil deeper layers of the star's atmospheric composition and dynamic behavior. These endeavors will shed light on the fundamental processes governing big stars and their ultimate fate. In conclusion, Betelgeuse stands as a celestial enigma that maintains to captivate and inspire astronomers worldwide. Its profound impact on our understanding of stellar evolution, supernovae, and cosmic dynamics underscores its significance in astrophysical research. As we embark on destiny explorations of Betelgeuse and beyond, we stay poised to find new revelations that enlarge the frontiers of human information and deepen our appreciation for the vastness of the universe.